I want you to hold a magnet in your hand. Maybe it's a fridge magnet. Maybe it's a toy. You can feel a tiny, invisible force pushing or pulling. It feels harmless. It feels like a magic trick. Now, I want you to imagine a magnet so powerful that if it was located on the moon, 240,000 miles away, it would wipe every credit card on Earth. It would suck the keys out of your pocket. It would pull the zippers off your jacket. And if you got closer, say within 1,000 kilometers, it wouldn't just pull your keys. It would kill you in the most horrific, sci-fi way imaginable. It would reach inside your veins, grab the iron atoms in your hemoglobin, and physically rip them out of your blood cells. It would jam the electrical signals in your brain instantly. It would distort the very shape of your atoms, turning you from a solid human being into a cloud of atomic dust. This isn't science fiction. This is a real object. It is called a magnetar, and it is, without a doubt, the most dangerous object in the known universe. To understand how something this terrifying can exist, we have to look at the death of a giant star. When a massive star dies, it doesn't just fade away. It collapses. Gravity crushes the core of the star inward. It squeezes a mass larger than our sun into a ball the size of a city, about 12 miles wide. This ball is called a neutron star. It is incredibly dense. A single teaspoon of neutron star material weighs 1 billion tons. If you dropped that teaspoon on Earth, it would punch through the crust and sink straight to the core. But in rare cases, about 1 in every 10 supernovas, something special happens. The star is spinning incredibly fast when it collapses. This rapid spin creates a dynamo effect. It amplifies the magnetic field to levels that defy logic. Let's look at the numbers. The Earth has a magnetic field of about 0.5 Gauss. This is enough to move a compass needle. A strong fridge magnet is about 100 Gauss. An MRI machine, the strongest magnet humans interact with, is about 10,000 Gauss. A magnetar? It has a magnetic field of 1 quadrillion Gauss. That is a 1 followed by 15 zeros. It is 1 trillion times stronger than the sun. So, let's play out a scenario. Let's say humanity builds a spaceship capable of traveling to deep space. We find a magnetar, and we decide to get close. At a distance of 1,000 kilometers, the magnetic field is so intense that it begins to interfere with your biology. Your nerve impulses are electrical signals. The magnetic field would jam them. Your heart would stop beating because the electrical signal from your pacemaker cells couldn't travel. You would lose control of your body instantly. But the physical destruction is worse. Atoms are usually spherical. The electrons orbit the nucleus in a cloud. But under a field of 1 quadrillion Gauss, the electron clouds are squeezed. They are compressed into thin needles. Chemistry relies on atoms being spherical. When they turn into needles, they can no longer bond with each other. The molecules that make up your DNA, your proteins, and your cells would simply snap. You wouldn't burn. You wouldn't explode. You would simply dissolve. You would turn into a cloud of monatomic gas and vanish into the vacuum. But the magnetar doesn't just sit there silently. It is active. Because the magnetic field is twisted and unstable, it puts immense pressure on the star's crust. Sometimes the crust cracks. This is called a starquake. On Earth, an earthquake moves the ground a few feet. On a magnetar, a starquake moves the crust by maybe a centimeter. But that centimeter releases a blast of energy called a giant flare. In 2004, a magnetar called SGR 1806-20 had a starquake. It was located 50,000 light-years away. That is on the other side of the Milky Way galaxy. Yet, the flare was so powerful that when it hit Earth, it physically compressed our planet's magnetic field. It ionized our upper atmosphere, making it glow. It blinded satellites. Think about that range. 50,000 light-years. If that magnetar had been within 10 light-years of us, it would have destroyed our ozone layer instantly. It would have triggered a mass extinction event that wiped out all life on the surface of Earth. That single explosion released more energy in 1/10 of a second than our sun will release in 100,000 years. We have detected these flares hitting us from other galaxies. For a long time, astronomers thought they were short gamma ray bursts. But now we know they are magnetars, screaming across the universe. Magnetars are the monsters of the sky. They spin incredibly fast. Some rotate hundreds of times per second. They're loud. They blast beams of X-rays and radio waves that sweep across the galaxy like a lighthouse. And, interestingly, they are short-lived. The magnetic field is so intense that it acts like a brake. It creates drag. Over the course of just 10,000 years, a blink of an eye in cosmic time, the magnetar slows down. The field decays. The star goes quiet. This means that for every active magnetar we see, there are millions of dead ones floating in the dark. Invisible, silent ghosts. Neutron stars that used to be killers, but have run out of ammo. We used to think black holes were the kings of destruction. But a black hole is actually quite polite. It will only kill you if you cross the event horizon. You can orbit a black hole safely if you keep your distance. A magnetar is aggressive. It reaches out and touches you. It attacks you from a distance. It dominates the space around it for millions of miles. It is a reminder that the laws of physics are not always our friends. We live in a very gentle, very quiet corner of the universe. Our sun is a stable, boring yellow dwarf. Our magnetic field is weak. But out there in the dark, the forces of nature are so violent that biology doesn't stand a chance. So, the next time you use a magnet to stick a picture to your fridge, remember what that force is capable of. Magnetism isn't just a way to hold metal together. In the right hands, it is a weapon that can tear the universe apart. I am your host. Keep your distance from the blue stars. Subscribe.